Hi, my name is Mohammed Saeed from Eurecom, and together with George Karagiannis from Cornell University and our respective advisors Paolo Papotti and Immanuel Trummer, we will be presenting our work. Several companies tend to store statistical claims in textual documents, which could be erroneous, causing several problems. They spend a lot of time and money trying to verify these claims using trustworthy databases. Scrutinizer is a system we built, which helps human fact-checkers by generating SQL queries for statistical claims from natural language sentences. We will describe Scrutinizer in details and see how it is applied to two use cases. The figure shows an overview of our system. The system has two components, a claim translation component and a question planning component. The claim translation component leverages machine learning in order to identify elements for the query to generate. For example, the classifiers find candidates for the tables, rows, attributes, and the comparison operations. The question planning component interacts with the human domain experts in order to verify these elements. Using cost-based optimization, the questions are prioritized in a way so that to minimize expected overhead. Same thing goes for the claims in the textual documents, which are processed in batches in a way to minimize expected verification cost. We now show the interface used to apply Scrutinizer with claims from the International Energy Agency, which is an organization based in Paris that works with several countries to shape energy policies. The sentence is shown on top with the claim highlighted in red. We then show screens for each query property, where each screen contains answer options coming from the classifier. We also have input feedback from the user if necessary. I will now go through some of the questions. We can see that each question asks for a certain query property. The final screen asks for the query related directly to the user, where it's ranked according to how close it is if numerical, or if it's true, then false if the claim is Boolean. We now do a quick demo of Corona Check. We first want to thank Johns Hopkins University for publicly providing the data. Basically, to make the system work, we input a sentence here, click on check, and the system verifies the sentence. At the beginning, we introduce a classifier which predicts if the input sentence is actually a statistical claim related to coronavirus or not. We can try one of the examples here, or you can provide any example you want. Let's try one of the sentences here. We can see that the system says that it is false, and to get an explanation, we need to click on the highlighted text. So once we click on the highlighted text, we get several properties. We get that the table used was total confirmed, which contains the total confirmed cases for each country in every day and month. We get the associated month, the country, and the value itself. And we also get the formula, which is basically a lookup here. The system is also available in French, Italian, and German. So we're trying here an Italian sentence. China has a mortality rate of 3%. And once we click on verify, we see that the system says it's false. And to get an explanation, we see that the formula is A divided by B. So to compute the mortality rate, we divide the number of deaths by the number of confirmed cases for a given place in a certain time period. And we get the actual value, which is 5.2% rather than 3%. Finally, since the system is trained on XLM, which is a pre-trained language model, we can benefit from its cross-lingual training by mixing multiple languages in one sentence. So here we're mixing French, English, and Italian together. And once we click on check, we can see that the system still verifies the sentence correctly. And you can see the associated explanation here. So in the end, we introduced Scrutinizer, a system that helps fact-checkers verify statistical claims. We apply Scrutinizer onto 2 use cases, one with the International Energy Agency and one on coronavirus statistical claims. Yet, several challenges occur when implementing Scrutinizers on some use case. For example, one of these challenges is finding relevant data sets for the associated use case. The second would be to cover non-statistical claims, as for now we only cover statistical claims. Another interesting challenge we are dealing with currently is dealing with language ambiguity. For example, let's say we choose the sentence, the death rate in Italy is much higher than in France. Now, this can be interpreted multiple ways because since the time is not explicitly stated in the sentence, one might choose to find cases for the month and one might choose to find cases per day. The other ambiguity is by the definition of death rate itself, as some define death rate as the number of deaths divided by the population, while the others define death rate as the number of deaths per the number of confirmed cases. This ambiguity might cause a problem since in some cases, an ambiguity might be true or false at the same time. So, for example, in this sentence, if we choose that the death rate is per population, then the claim itself is true. While if we choose that the death rate is per total confirmed cases, then the sentence is false. Thank you for your time.